How did we do it? This video demonstrates how to solve the Your Turn problems on interval class. Let's look at number 1. We have the pitches A and C. The first step is to circle the pitch classes on the clock face. C we already know is pitch class 0, so we can circle that and write 0 in the blank underneath C. For A, it's easier to count backwards from C down to B, B flat or A sharp, and then to A. We can then circle pitch class 9 and write 9 in the blank under A. Now we've completed steps 1 and 2 for this problem. The last step is to write the interval class in the blank below the pitch class numbers. We'll look for the shortest path between the two, which I've shown with an arrow between 9 and 0. Now we count how far apart they are. 1, 2, 3, half steps away. Our answer is interval class 3, which we can then write in the blank. We're done with the last step for this problem. In the text and previous videos for the topic of interval class, I showed another method for finding it that references familiar diatonic intervals instead of the clock face. For the sake of time, I won't reproduce the pitch class chart here or explain the interval class chart shown at the bottom of the screen in detail. The interval from A to C is a minor third, which is interval class 3, the same answer we got using the other method. Let's move on to problem 2 and start with the first two steps, circling the pitch classes on the clock face and writing the numbers in the blanks. Our first pitch, B flat, is not that far below C, so it's easier to count down to it from C to B and then to B flat. We can circle pitch class 10 and then write it in the blank. The second pitch is E flat, and we can easily count up to that from C to C sharp or D flat, D, and then to E flat. Our answer is pitch class 3, which we circle and then write in the blank. We've now completed the first two steps. Finally, let's find the interval class. We need to start by finding the shortest path between them, shown with the arrow, and then count the distance. 1, 2, 3, 4, 5 half steps away. We write the answer, interval class 5, in the blank to complete this problem. Let's check our answer to number 2 using the second method. The interval from B flat to E flat is a perfect fifth, which is under interval class 5 on the chart, the same answer we had from the clock face method. Now let's look at number 3 and begin with the first two steps. We have the pitches G and F sharp. Let's use a shortcut detailed in the videos on pitch class. Recall that pitches that are a tritone apart are across from each other on the clock. We know that F sharp is a tritone away from C, so we can draw a line from C at 0 to F sharp at 6. This is one pitch class number you should try to memorize. So we'll circle that and then write 6 underneath the F sharp. We know that G is only a half step above F sharp, so we know it's pitch class 7, which we circle, and then write under the G. We've now finished the first two steps. Now let's find the interval class. The shortest path between them is pretty obvious since they're right next to each other, or one half step away. Our answer is interval class 1, and we're done with this problem. Let's look at that same problem using the other method. The interval from G to F sharp is a major seventh, or an upside down half step. This is categorized under interval class 1 on the chart, confirming our previous answer. Finally, let's try the last problem, pitches A flat and D. From C, it's easier to get to A flat by going down, so we move to B, B flat or A sharp, A, and then we reach A flat, which is pitch class 8. We circle it, and then write it in the blank. D is a little easier because we can count up from C to C sharp or D flat, and then to D. We circle pitch class 2 and then write that in the blank. This completes the first two steps. For the last step, finding interval class, we normally look for the shortest path between the two numbers. However, we can see that either way we go, we get the same distance. This is because the two notes are directly across from each other on the clock. So it really doesn't matter which direction we go, we'll get the same answer. 1, 2, 3, 4, 5, 6 half steps. We can write this answer, interval class 6, in the blank to complete the problem. Using the interval class chart for the same problem, we first measure the interval between A flat and D, which is a diminished fifth or tritone. The tritone is interval class 6, the same answer we got using the other method. And that's how we found the solutions to these your turn problems on interval class.